Hi, I'm Connor,
I'm Adam.
And I'm Eric.
and this is the history of radiation and their different types. Radiation was discovered in 1895 by William Röntgen. He discovered it by passing current through a vacuum tube. Despite that there was nothing leaving the tube, something was reacting with the barium solution on the counter. He called this X-ray radiation. In the year 1898, Henry Becquerel discovered that uranium salts gave off a similar type of ray. In 1899, Rutherford defined the two different types of radiation as alpha and beta radiation. In 1900, Paul Villard discovered gamma radiation, though it wasn't called that at the time. Now we will discuss more in depth the different types of radiation, starting with Eric discussing X-rays.
X-rays are radiation that occur when an electron moves from a higher energy state to a lower one. Atoms have different levels of orbitals, or shells, that electrons orbit their nucleus. The farther out the shell is, the more energy is needed for an electron to stay in that particular orbit. And if there's a free space in a lower shell, an electron has to fill the gap. In order to do this, it would release energy in the form of X-rays to get to the lower energy state and therefore the lower shell of the orbit. Other ways X-rays could form is Bremsstrahlung radiation and electron capture. Bremsstrahlung radiation occurs when an electron passes close to the nucleus of an atom and is slowed down by positively charged nucleus. The loss of speed is emitted as energy, which is in the form of X-rays. Electron capture occurs when a proton-rich nucleus of an atom absorbs one of its own orbiting electrons. The proton is turned into a neutron and the energy emitted is in the form of X-rays. X-rays were discovered in 1895 by Wilhelm Röntgen when he was experimenting with cathode ray tubes. For one of his experiments, he covered the tube with a black cardboard box so its visible light would not interfere with what he was trying to do. When he did this, he noticed a sheet of paper coated with barium platinocyanide started to glow. This intrigued him, and he started to put things between the sheet and the box to make sure the glowing effect was coming from the box and not some other source. He then noticed only certain material would block the glowing and eventually discovered that it would show the bones in his hands when he was holding things in front of the paper. He then labeled these new rays of energy X-rays, because X means unknown in science and math. Later on, in 1901, Röntgen won the first ever Nobel Prize in Physics for the discovery of these new rays. It wasn't long after the discovery of X-rays that people started finding uses for them. They were used for amusement, treatment, and diagnosis. The first picture of human hand was that of Röntgen's own wife. And eventually shops were opened up so people could take pictures of their skeletal structure to hang around the house. In 1896, X-rays were starting to be used for treatments of illnesses like cancer and rheumatic pains. In the case of rheumatic pains, the X-rays did seem to alleviate some of the pain. This boosted X-rays as a viable treatment method, but it would not last for very long. By 1897, there were 69 recorded cases of skin damage that were due to X-ray exposure, and by 1902, that number grew to 107 cases. By 1907, there were 7 deaths that were the result of X-ray treatment. As time went on, stricter rules were implemented on the amount of exposure one can receive, and its uses as a treatment tool started to diminish. This wasn't the end of X-rays, though. There were other uses that it provided that still greatly benefit society even to this day. Today, X-rays are used for a great many things, from medicine, security, and even exploration. In medicine, we still use X-rays to peer inside living organisms like humans instead of cutting them open. It is also used as a great diagnostic tool for non-medical professions. It can be used to find stresses and fractures in material walls, as well as peer inside containers that would either be too expensive, damaging, or dangerous to open. They are also used in security checkpoints around the world to make sure no contraband is brought into or out of controlled areas. X-rays are even used in space. This is because they have great penetrating power and are able to penetrate through the vast dust and gas clouds that exist in the center of our and other galaxies, giving astronomers much better source of information than telescopes that only observe in the visible spectrum can. And now here's Adam with alpha and beta radiation.
What is a helium? What is an alpha particle? An alpha particle is a helium ion that has no orbital electrons. This means it has a charge of +2, and its mass is 4 amu. That means it has 2 neutrons and 2 protons. This means that it causes lots of ionization in a short distance. But because of its mass, it's very slow and can't penetrate very far, and the dead layer of skin that we have protects us from it. However, if this type of radiation gets inside of us, it's very damaging. How was it discovered? Alpha and beta radiation were both discovered by Becquerel in 1898, but he didn't know what they were at the time. Alpha and beta radiation were both defined in 1899 by Ernest Rutherford and Paul Villard. Defined each radiation because of its penetration into objects. In 1907, Rutherford and Thomas Rhodes proved with an electrical field that an alpha particle was indeed a helium ion. Some of its uses. Alpha radiation between 1973 and 1987, there was a total of 155 nuclear pacemakers, which were implanted in people. But due to concerns from radiation and the rise of lithium batteries, they became obsolete. Another use is the use as static eliminator for industrial processes. This means that they collect loose electrons in the air when industrial stuff is going on. There is research being done about using alpha radiation nucleotides and directing a small amount towards a tumor. This is called unsealed source radiotherapy. Another use of alpha radiation is in space probes. They use it in a radioisotope thermogenerator that uses the heat that's given off from the decay of alpha radiation, and the heat is converted to electricity, which then powers the space probe. And now I will talk about beta radiation. Beta radiation. Beta radiation is a high energy, fast moving electron, or positron, emitted from the nucleus of an atom that undergoes beta decay. This beta decay can either be beta positive or beta negative. In beta positive decay, a proton is converted into a neutron, and the nucleus emits a positron and a neutrino. In beta negative decay, a neutron becomes a proton and the nucleus emits an electron and an antineutrino. The emitted positron or electron will have a positive or negative charge respectively, and both will have a mass of 1/1840 AMU. Beta radiation is more penetrating than alpha radiation, but less than gamma. Its penetrating capabilities are dependent on the amount of energy the particle has, but typically fall under 0.1 to 3 MeV. Each nucleotide will have their own specific max EV, but the average energy of the beta particle will be about 1/3 of the max EV of that specific nucleotide. Some of the usage of beta radiation. Beta particles can be used as an illumination source when tritium, which decays by beta radiation, is matched with a phosphor material. The beta particle that is emitted from tritium, when it decays, interacts with the phosphor, exciting its atoms, and they release photons in the form of light. These are good in emergency situations because they require no source of electricity and last as long as the tritium is still present. It's also used in quality control for measuring the thickness of material, such as paper. This is done by passing beta radiation through a material and measuring what radiation actually makes it through and is not absorbed by the paper. If the material changes in thickness, then the amount of radiation that makes it through will also change, and this change is measured by a computer, so adjustments can be made to the manufacturing process. Medically, beta radiation is used to treat certain types of cancer, like bone and eye cancer. And now here's Connor with gamma radiation.
Gamma radiation is electromagnetic rays that move at the speed of light because it's a form of light. It has a short but strong wavelength, making it very powerful and dangerous. Gamma is given off by most sources that give off beta and alpha radiation, but some sources give off strictly gamma radiation. Gamma comes from four main forms: fusion, fission, gamma decay, and alpha decay. Gamma decay occurs in the nucleus. Happens when the nucleus is excited and then returns to a ground state. A nucleus can get excited when an alpha particle, a nucleus, leaves a heavy atom, and that heavy atom releases the unwanted leftover energy as photons, light, and to internally stabilize, which is gamma decay. So alpha decay leads directly into production of gamma radiation. It can also happen with fusion and fission reactions. Fusion is when two nucleuses of two different elements combine to form one nucleus, whilst fission is the opposite. In both cases, nucleons are excited from the conversions and gamma rays are formed. Since gamma is a ray, it has the same properties as X-rays. The only difference between the two is where and how they're formed and their energy outputs. Gamma comes from the nucleus, whilst X-rays come from the outside of the nucleus. Gamma is also way more powerful, with photon energies being beyond 100 kiloelectron volts. The history of gamma radiation. Gamma rays were first observed by a French chemist named Paul Villard when studying radium in the year 1900. Ernest Rutherford proposed the name gamma for the new type of radiation in 1903 to follow suit with the other types of radiation, alpha and beta at the time, in suit with their Greek characters. Until 1914, It was thought that gamma radiation was just a super fast beta radiation, a particle instead of electromagnetic energy, or a wave. Rutherford discovered it was a wave after focusing at a crystal and observing the energy reflecting off of it. He also attempted to change the course of the gamma radiation by using magnetic fields, but since the rays hold no charge, it had no effect, and Rutherford concluded that they weren't particles and were similar to X-rays. Usage of gamma radiation. A gamma knife is a form of radiation treatment which is mainly used on brain tumors. By using a focused beam of gamma rays, tumors can be killed with less risk of manual surgery or in places where a scalpel can't go. Astronomy and observing the stars. Many things in the universe give off gamma rays, and this allows us to observe things that are out of our standard reach. Similar to X-rays, gamma rays give us much more information on masses that are obstructed by gas clouds and debris.
Thank you very much for listening to our presentation on the history of radiation.